All right, as we continue to talk about functions, we need to discuss function notation and make sure that you know how to use function notation. So here is an equation, f of x equals negative x times x plus 5. This is function notation. Whenever I represent y as a function of x, then instead of writing y equals negative x times x plus 5, I change it and I write a function of x. And that is how you read this. It is, you can say f of x, or you can say a function of x. F of x equals, or a function of x equals. This does not mean f times x. All right, so let's suppose, using our equation, that we want to know what f of 2 is. Well, that means that I want to find y when x is 2. So to find y when x is 2, then I'm just going to put 2 in for x. I put my negative sign down, I put 2 down, and then in parentheses here, put 2 where x is, and then plus 5. So everything in my equation is exactly the same, but I'm putting 2 in everywhere that there is an x. All right, well, let's do the math. So this is negative 2 times 7, or it's negative 14. So this means that when x is 2, y is negative 14. Or it also means that negative 2, 14, or sorry, when x is 2, positive 2, negative 14. The point 2, negative 14 is on this curve if I were to graph this. All right, well, let's suppose we want to find f of a. A is not a number, but that's okay. You can put anything in these parentheses. You can put your name in those parentheses. And all you're going to do is replace x with whatever is in the parentheses. So f of a is going to be negative. Remember, I write everything else exactly as it is. So it's negative, and then I put a in for x. And then in the parentheses, I have a plus 5. Well, what about f of, and we can simplify this, by the way. You can say it's negative a squared minus 5a if you want to, okay? What if we put x plus 1 in those parentheses? What is f when x is really x plus 1? All right, well, here's my negative sign, and then x plus 1, and then in these parentheses I put x plus 1, and then plus 5. So really I have negative x plus 1 times x plus 6. And I can multiply that out, and I get negative x squared plus 7x plus 6, or I get negative x squared minus 7x minus 6. So this is what y is when x is really x plus 1. All right, well, let's suppose that, one more thing, that we want to have a number on the outside, like I have, let's say I have 3 times f of 4. What is that? Well, this means that I'm going to multiply, now I am multiplying, I'm multiplying 3 times my function when x is 4. So first, I want to find out what my function is when x is 4, and then I want to multiply 3 times that. Well, my function when x is 4 is negative, and then I put my 4 in for x, everywhere that x appears. And so you have 3 times what's in parentheses. So 3 times, and then negative 4 times 9, or 3 times negative 36. So 3 times f of 4 equals, and then whatever 3 times negative 36 is. So that's negative 108. All right, this means that 3 times y when x is 4 is really going to be negative 108. Well, let's close this with a real-life application of function notation. Let's suppose that you're going to give a party, and you have already spent $12 on paper goods for your party. Okay, so you are giving a party. You've spent $12 on paper goods. But the food is going to be determined by how many people come to the party. All right? And so you've estimated that the food is going to cost about $5 per person. That means that your cost for this party, your cost is going to be a function of the number of people that come to the party. So we can write that as C of N, and we can say that that's going to look like 12 plus, because I've already spent $12 on paper goods, okay? So my cost is going to be equal to the amount of money I've already spent plus $5 times the number of people that come. So 5 times N. So you see, my cost is a function of N. My cost is determined by what N is. This means that if 10 people come to my party, then C of 10 equals 12 plus 5 times 10, or it equals $62. Okay? If 20 people come to my party, then C of 20 is going to be 12 plus 5 times 20, or $112. So you see, this is a real-life application of function notation.